Well, hello everyone. I'm Paul Drabble, Global Marketing Director at Delta Q Technologies, a member of the Zappi Group of companies. I'd like to extend a warm welcome to everyone tuning in for today's last session, Sustainability in Transportation, Beyond the Hype and the Rhetoric. It's my pleasure to introduce our speaker for today, Dr. Ray Gallant, who is the Vice President of Sustainability and Innovation for the Americas region at Volvo Construction Equipment. Ray is responsible for developing and executing Region America's sustainability strategy for new products and technologies. Before we begin, if you have any questions during this session, please add them to the Q&A tab to the top right of your webinar screen, and note that your questions will be sent privately. At the end of Ray's presentation, I'll facilitate a brief Q&A answering the audience questions in the order they are received. With that said, I would like to hand off to Ray. The session is now yours.
Thank you very much. Thank you everyone for attending this session. I'm excited to be presenting at this conference and to be presenting our ideas on sustainability and transportation. And what I'm going to do in this presentation is talk quite a bit about some of the hype and rhetoric and the changes we've seen in the sustainability journey in the last 5 or 6 years since we've been doing this and promoting sustainability in the heavy equipment realm and sectors. So if you take a look at my background, I am an engineer by trade, 2 science degrees and a Master of Science in Management. So my approach to these things is very much data-backed and data-centric. So I tend to like to look at the data and see the trends that are going on, and you'll see that in my presentation as I get into it. I ended my academic career, or my latest academic endeavor was a DPA in international business, which brings in a lot of the business aspects of what I'm going to talk about in the presentation as well. So it's not only how do we engineer and get the technology to work, but it's how do we make it business viable. Which brings me to our view on sustainability. So we view sustainability at Volvo as being a combination of 3 pillars of the social sustainability. That's what society is asking us to provide as a company, as a corporate citizen. There's environmental sustainability, which has caught a lot of the news in the last few years. So how do we use our resources that we're given wisely and recycle them as much as we can and repurpose them so that we get a longer use out of them and not just dispose of a half-used or poorly used natural resource. And finally, the third leg of this endeavor is economic sustainability. So there's no sense having social sustainability and environmental sustainability if you don't have an economically viable platform to build on them. By definition, if it's not economically sustainable from a business point of view, you go out of business, you go bankrupt. So that's not a very sustainable company that's not economically viable. So we view this as the 3 legs to the stool, and all have to be in balance to make this a successful endeavor ongoing.
At the heart of Volvo Construction Equipment lies a commitment to people, sustainability, innovation, and a rich history of pioneering progress. We've been at the forefront of innovations since we were founded in 1832. We empower individuals worldwide, valuing their skills, passions, and diverse perspective with the purpose to build the world we want to live in. Today, we have a network in every major market, stretching across 180 markets around the globe. As a global leader in construction solutions, we have a responsibility to continuously strive to find new, better, and sustainable ways of working by leading the transformation with premium products and services that combine business outcomes with care for people and planet for a better tomorrow. Through sustainable development, innovation, diverse and ethical conduct, we aim to be a leader in sustainable site solutions to create a safer, cleaner, and more connected world. Together with our partners and customers, we fulfill promises, earning trust and advancing towards our shared vision with quality and safety at the center and with people in mind. Every day, we choose to act on that cause for our and future generations, not just because we can, because we want to build the world we want to live in.
So the tagline from this video is very much our tagline and our operating principle today. So we want to build the world we want to live in. We want to be a part of leading towards a better world for the next generations to come, and a world that we would want to inherit if we were up and coming in the industry. Volvo is not new to this journey. So we've had environmental care as a core value for 30 or 40 years now, but really got into the electrification journey about 10 years ago, starting with Volvo buses. So we've been running electric system, electric drives in our bus line for over 10 years, for almost 15 years now, and learning from that, bringing the components forward and the industry forward uh, towards electric drives. So heavy equipment, we started in 2019. Actually launched at ConExpo in 2020. The ConExpo that was not because of COVID. And in that year, in 2020, you can see that we produced 302 electric machines within the Volvo Group. Fast forward 5 years later, we're at 2024. We've produced 6,392. So a pretty good growth over 5 years. And in 2025, we ended up at 7,602 machines produced that are fully electric drive and electrification offerings to the market. So this has been a fairly rapid journey, reacting to the needs of the customers and society going forward. So the next question is really what is driving this drive towards more sustainable solutions and more sustainable practices in our industry. So I look at four different trends that are driving this forward. So political trends definitely are part of it. They are moving us forward. What the government and the society wants us to do in terms of sustainability is usually defined through the regulations, the laws that coming out of our politicians, coming out of our governments. But there are other trends that are affecting this as well. So we are seeing a rapid move to urbanization around the world, and that's basically the phenomenon of people moving out of rural areas and into heavily populated areas or cities, in other words. We are seeing a lot of movement in technology over the last few years, not only in the innovations coming out in technology, but in the pace of technology changes and technology adoption is rapidly accelerating. And we are also seeing a difference in the energy outlook around the world. So different types of energy are being phased out, and different types of energy generation are being brought in. But certainly the demand for energy, if you look at data warehouses and AI, is going up exponentially as we speak. So if we take a little bit deeper dive into these, um, political and social uncertainty definitely is a driver in the last few years. Um, we're seeing right now some different tariff regimes imposed on us. We're seeing a war in the Middle East or a conflict in the Middle East. All those things are drastically affecting our political situation and the geopolitical situation worldwide. And of course, when it comes to energy markets, there's a big impact, and that has a big impact on what we do in electrification and changing fuel sources going forward. But there's other effects beyond that. So the entire social interaction of our societies has changed over the last 20 years, where we've gone from a very hierarchical organization, social organization, to more of a networked world. So what that means is we're not necessarily looking to one group or one person, our superiors, in other words, as to what we should do socially, but we're looking towards networks. So in a network, anybody's opinion can be heard, and you don't necessarily know the credibility of a certain opinion on the World Wide Web, for instance, on the internet. So it makes a very different organization when you're trying to look for what are the facts, what is the truth, what is AI generated versus what is the actual data that you're looking for. So this is something that we have to wrestle with and is a part of the AI equation going forward. If we look at urbanization, as I mentioned, the trend is for people moving from rural areas to cities. If you look at the population in 1950 worldwide, we were about 2.6 billion people. And by 2050, it's projected to be approaching 10 billion people worldwide. We are currently at 2018, we were at 7.6. And the percentage of urban dwellers in 1950 was about 35% of 30% of the population. By 2018, it had climbed up to 55%. And by 2050, they're projecting 68%, the United Nations is. But the reality is that by 2018, 2019, we had already surpassed 55, and we're already well on our way to that 68%. So that's going to probably be eclipsed before 2050. And this phenomenon is also showing up in terms of the urban centers. So in 1950, we had one mega city, that was New York City, that was the only city that we considered the city boundaries had 10 million people in it. By 2018, worldwide, there was 33 such cities. And by 2050, we're looking at 60 plus urban centers that are 10 million and more. And in fact, we've invented a new term since 2000, which is a meta city, which is 20 million people plus. And we're already at 5 or 6 of those worldwide. So what that does when you look at it is all of the raw materials that we're consuming and processing generally come from the urban areas, from the rural areas, and are going to be produced in the goods that are consumed within the urban areas. So you're having a shift from 30% urban, 70% rural, and the rural would, of course, produce for themselves and the 30% urban dwellers. Now that ratio is completely shifted, and we're looking at roughly 30% that are urban, that are rural, trying to supply all the raw materials and process all the goods for the 70% living in cities, and including transporting all the goods. So the shift is dramatic. The shift has a big effect on how we do things and how efficient we have to be in producing this, all the goods with 30% of the population to feed the other 70% that are city dwelling. Technology, as I said earlier, continues to change and it advances in cyclical waves, but more rapid as time goes on. So the pace of technology continues to change and accelerate. The newest technologies that we're looking at are AI and data driven. We still are in the middle of the information age. So these we consider to be the next technologies that'll carry through and be dominant for the next 20 or 30 years. Uh, but we are already starting to look at what is after that. And we don't know what that is. It could be biotechnologies, it could be nanotechnologies, it could be a number of different technologies coming out. But we're pretty sure if you look at history and technology development over time, that there will be a new set of technologies emerging in about 20 or 30 years that'll start to be the dominant technology. They won't dis
and data analysis and data unity, and the new technologies will be in another realm.
in another area. And finally, we can look at energy. And this is a very interesting chart that correlates the global energy consumption or availability in terawatts, which is a trillion watts, with the global GDP. And if you look at what's happening is from 1900 to 1970, you had an R squared of 0.99%, which is almost a perfect correlation to the line. And what it said is basically with an exposure of 0.98, that you had a perfect correlation or almost perfect correlation between every unit of GDP growth or energy growth would give you a unit of GDP growth. After 1970, the slope of the line changed a little bit. So it's still a very, very good correlation. In fact, it's a better correlation, but the slope of the line changed a little bit. So for every 2/3 of a unit of energy on this chart, you went up 1 unit of GDP. So what that means essentially is energy is a very good correlation. Energy availability and cost is a very, very good correlation to global GDP. In fact, the best correlation that we have, better than interest, better than currencies, better than any other factor that we have in economics. But it has changed over time. And what happened in 1970, 73 actually, is that we had the OPEC oil crisis, and we learned how to be much more efficient with our energy usage. So for every unit of energy since the 1970s, we've been producing more GDP growth, which is good news. That's what we should be doing, is getting more and more efficient over time. So if you take a look at the world energy consumption, and this brings us back to what are we going to do with electrification? This chart I find a little bit startling because if you look at it, the top 3 lines there accounting for most of the world production are still very heavily fossil fuel dominated. In fact, they are petroleum, natural gas, and coal are the top 3 lines for worldwide basis. Worldwide, we do 175,000 terawatt hours of energy per year is a consumption. And if you take a look at all the renewables around the world, that's still only 10,000 of that 175. Nuclear is less than 10,000 of the 175. And
Is obviously
okay, what's the situation in the US? What are we looking at? It's a little bit better picture in the US, but still very, very similar. So you see that petroleums and natural gas are the 2 dominant energy sources. We've done a good job getting coal down significantly from where it was just 15 years ago. In 2008, 2009, coal was about 6 to 7,000 terawatt hours of energy consumption. Now it's down to less than 2,000. So we cut it by about 2/3, replaced by natural gas in our fired power plants. So that is a very good step. But you do see the renewables, even though we've put a lot of effort into developing our renewable sources, solar, wind, hydro, all those other renewables, it still only accounts for a fraction of about 9% of the total. You also see that nuclear has pretty well tapped out. It's running steady from what it was in the 90s. And the problem is that some of those nuclear plants are now coming offline. So we're actually seeing a decline in the nuclear plants, and we're seeing utilities are starting to scramble to try to bring some of them back online or replace some of them with new nuclear generation. Because we're at the same situation that we're seeing worldwide, is you cannot at the moment replace all the petroleum fuels or the fossil fuels with electricity. It's just not feasible to try to do that in very quickly one step. Where the energy comes from does make a big difference. So if you look at a machine, and now I'll bring it right back down to the machine level. So a machine that's a diesel run machine with an internal combustion engine, if I wanted to generate about 5,000 kilowatt hours out of that machine, and that's about enough to power your house, an average house, for about half a year. So it's a fair amount of energy. I consume somewhere around 622 gallons of diesel. If I know that a gallon of diesel consumption produces about 10.19 kilograms of CO2 equivalents, that gives me a total of about 6,335 kilograms of CO2. So that's running a machine to produce 5,000 kilowatt hours of energy or work, if you want to think about it that way. That same 5,000 kilowatt hours, if I was to produce it out of hydro generation, hydro generation is not 100% clean. There is some embedded carbon in our hydro generation as well, but it's far, far less. It's about 99% less than burning diesel. So obviously, if I can plug in my machine and I'm running off a hydro generated electricity, I'm getting about 99% less carbon, or about 55 kilograms compared to 6,335. So big step forward. But most of our electricity is not hydro generated. As I said earlier, only 9% of our total grid is supplied by renewable sources. So there are very few people actually have access to 100% hydro generated. So what if we look at coal? So pulverized coal without carbon capture, we're only looking at 14% less CO2 than the burning diesel. So actually, if you're plugging in and taking from a coal-fired plant that doesn't have a good carbon capture system for the electricity generation, you're not gaining anywhere near as much as you thought you were. Even though the machine may be zero emission or very low emission, the coal is producing a lot of emissions at the power plant. And finally, I quite often get asked, okay, what if I charge my machine with a diesel generator because I don't have access to the grid? A lot of people think that we're not gaining anything. The actual reality is that you're gaining about a third of this less CO2 than burning diesel directly in your machine. So even that is a significant step forward if you're looking at where the carbon is coming from in the carbon cycle. So let's drill down and take a look at an example sample that we did. This is a real world example that we did. But first of all, I want to step back and say, okay, if we're going to look at machines and how we make a difference, it's not machine by machine. We have to look at how do we get a site to be sustainable. And there's two reasons for that. One is that electrifying one machine only makes a limited amount of difference versus electrifying a site with many machines on it. And secondly, if you're going to run the infrastructure to electrify machines on a site, you don't want just one machine plugging into an infrastructure and having to run a full diesel infrastructure as well. So you want to make the transition and have as much of your site transferred over as you possibly can. So we look at this in three steps. One, what is the machine technology that we're going to need to achieve sustainable sites? Two, what is the system that you need? So in other words, how do you recharge or refuel your machines and your trucks and your conveyors and everything else running on site? And three, how do we run that whole system more energy efficient? Because going right back to the grid, the same dynamics happen on a site. If you can get your energy consumption down, your costs, your economics are much, much better on a site. So if we look at the CO2 production on a site, in our case, most of our CO2 production comes out of burning the fuel on site. So in fact, if you look at our heavy equipment, an A45, for example, a 45-ton articulated hauler, 94% of the emissions come from the machine, or the carbon comes from the machine after it leaves the factory. Only 6% is embedded in the machine throughout the build process. The energy consumed in building it, all those factors are only 6%. So obviously, if we have a target to get 30% of the carbon out or 50% of the carbon out, whatever the individual targets are, we have to attack that 94% in the machine cases. And we do that by looking at three different technologies and bringing them together to try to make the best use of them we can. So the technologies coming up of digitization and AI, if we understand the sites, we have good data from the sites, if we use AI wisely, we can make sites that are much more efficient from an energy point of view, from a time point of view, from a production point of view, and get those costs down and the fuel burn down and get to a less carbon intensive site. We can also look at the sustainable power technology. So how can we power our machines to get that 94% of fuel burn down considerably and get the carbon from that eliminated? And finally, we can look at automation. A lot of people challenge us on that and say that, well, if you're automating sites, you're taking away jobs from operators. In our case, we're having a big shortage of skilled operators already. We can't get enough operators to do the work that we're asked to do. And most of these automation systems actually go into helping the operator do a better job or getting him out of dangerous situations. So when I talk about automation, don't just automatically assume we're eliminating the operator. In most cases, it's actually helping the operator or getting him out of what we call the 3Ds, dirty, dangerous, or dull jobs, and getting machines to do them or robots to do them automatically. And from those three technologies put together, we've come up with 5 solutions for sustainable power that we can look at. One is battery electric machines, which are already appearing on the market. We have a whole class of alternate fuels. So instead of burning a fossil diesel, we can burn renewable diesels. We can burn biofuels, which have much less carbon content. So there are other alternate fuels. We can grid connect the machines directly. So you can run an umbilical from your grid to the machine and operate it that way. We can do hybrid systems, which it may be a small diesel or alternate fuel engine powering a generator, charging a battery to extend the life of the duty cycle of the machine, or it may be a hybrid system. So instead of converting battery electric to hydraulic to power and attachment, we may want to go battery electric directly to the attachment and gain much more energy efficiency there. And finally, hydrogen, which gets a lot of press, and that can be either hydrogen fuel cells or hydrogen combustion in a conventional modified internal combustion engine. And if you look at those 5 solutions, the next question would be obviously, where do we expect to see those as being practical solutions going forward? So we're already seeing smaller machines come out with battery electric systems. In our case, most of them are 48 volt. If you get to mid-sized machines, we go up to a 600 volt system, which gives you the ability to charge and discharge energy faster. Doesn't necessarily give you more energy density. In fact, it doesn't give you more energy density in your batteries, but it gives you the ability to move energy through the batteries at a much faster rate and much safer operation from that point of view. If we get above about 150 kilowatts per hour, kilowatt hours per hour, and we get to long duty cycles, so 10, 12 hour to 24-hour duty cycles, we pretty well have to look at some of the other solutions. Batteries just become too expensive, too heavy, and too long a charge cycle to make it practical in heavy equipment. So we go to hybrids or alternate fuels in those classes. And if you get to the very large machines, you can do a fuel cell or alternate fuel ICE systems to power those. In the mid-size and larger machines, there's also, if you have an application where that's applicable, you can power them directly from the grid if you have a relatively stationary application. So in other words, you plug in your machine and it operates from the grid power continually. So our sustainable power journey, we have 6 machines in a 48 volt range and 2 machines in 600 volt plus that are marketed in North America. These are commercial available products. So we've been putting them out for a few years now and have quite a bit of experience with them. And over the next couple of years, you'll see a number of other products launched that are either battery electric, grid connected, even fuel cell and hydrogen possibilities will be coming out of the Volvo Group. So if we take a look at an actual pilot we did, and here I want to delve into the, are we really making a difference if we electrify a machine? I quite often get challenged on different aspects of this, of how much difference does it really make to put electric machine, and is it viable economically? So we wanted to look at actual data from some of the trials we did and see if what is the case there, what is the situation. So we looked at a case down in San Diego. It was a 220 electric, 20-ton excavator. Excuse me. The diesel equivalent to that machine burns about 4.05 gallons per hour. And if you multiply that out with the CO2 produced in 122 hours, which was the trial working period, you get about 5,000 kilograms of CO2 produced. With the electric 230, same job, same amount of time, we consumed 4,536 kilowatt hours of electricity. And the grid in that particular area in San Diego had 218 grams of CO2 per kilowatt hour, which gave us 989 kilograms of CO2 equivalent, which gave us about an 80% reduction in CO2 running the diesel machine, the electric machine instead of the diesel machine. Now, probably for most of you, 4,000 kilograms, that's really hard to picture. It's really hard to see what that is. So to put it in perspective, that would be the equivalent running one electric machine, 20-ton excavator, is the equivalent of about 13 passenger cars. So if you ran one machine for a year, you take about 13 cars off the road that are burning gas or diesel. So one of the objections that I quite often get is, yes, but an electric machine is much more carbon intensive. You have a lot more embedded carbon when you build it. Absolutely true. So to build a diesel machine, I'm embedding about 84,000 kilograms of CO2 per machine, mainly in the steel that goes into the machine. Steel is a very carbon intensive process, the way we do it today. So we end up with about 84,000 kilograms. With an electric machine, because of the batteries, that jumps up to 108,000 kilograms, which is a 28% increase. So the critics that say we're embedding more carbon, absolutely true. We're not going to deny that or argue around it. We are embedding more carbon in electric build. However, when you start using the electric, because of the fuel savings, you offset that 28%, that 23,000, almost 24,000 kilograms, you offset it in about 800 hours of use. And by the time you get to about 4,000 hours of operation, 4,400 hours, you've offset the entire machine's carbon production, or the difference in carbon for an entire machine. So what that means is if you were to buy a machine, an electric machine, and park it and not use it, you've actually done harm to the economy, because we've actually embedded more carbon in that buy than you saved. But the minute you start using that machine, and as the hours add up on the machine, then you're making a significant difference going forward. So then the next question is, okay, what are the economics of this equation? If we look at that, not just the carbon, what are the economics? So you take the same trial again, diesel twin, we burn 4.5 gallons an hour. And in this case, we were paying about $5.29 per gallon of diesel delivered to site. Because remember that most of our work sites are remote, as this one was. So we have to get fuel brought in. So the price, today's dollars, that's a pretty comparable price. But even at the time, diesel was running about $4.25, I think, at the time. And there was about $1 surcharge to bring it in delivered on site that the contractor had to pay for. Comparatively, the electricity, the kilowatts he used, was about 10.49 cents a kilowatt hour if he charged or recharged in off-peak hours. If he charged in peak hours in this particular area, it was about 400% more. So it's about 45 cents a kilowatt hour. So that peak charging or charging makes a big difference. And that's part of the site plan that I was talking about. But what it ended up is, if you look at the fuel savings, he saved about 82% of the cost in the fuel saving. And these are the actual numbers from that 122-hour trial that the contractor ran on site. So one of the objections to that is, well, or one of the questions of that is, well, what about the other costs that go into operating an electric machine compared to a diesel? So it's fine if you've got 82% energy cost savings in this case. We estimate that repair and maintenance, because there's less moving components in electric, that those costs are going to be about 35% less than a diesel machine. But some of my critics say, yeah, but wait a minute, batteries don't last as long as, we're saying a diesel engine might. So what if their battery goes down after, what if your battery degrades, so that after 12,000 hours or after a period of time, you have to replace the battery? So we said, okay, let's replace the entire battery at 12,000 hours, which is a very, very conservative adjustment. We think the batteries will last more like 18,000 hours before they have to be replaced. And there's a second life on those batteries. So it's not like a fuel tank where when you pull it out, throw it away, it's just sheet metal. The batteries will have a second life application and a value even when you replace them. But even if you take the full replacement with no recovery, you're still about 6% ahead in repair and maintenance with the electric machine. And then you have 100% recovery of your DEF costs, because electric machines obviously don't need diesel exhaust fluids to go. So if you take this and plot it over the life of the machine, so what I've done is plot a 220 ICE machine, or internal combustion diesel machine, with the assumptions down the side. So this was, again, based on that use case that we did. Fuel at 5.29, electricity at 10.49, interest at 8% on the money he had to borrow. And the price of an electric, we said at this time, was about 1.7 times diesel. Okay. We said 2,000 hours a year of working, and this included the maintenance and the DEF. So that would be his cash flow over the life, or over the first 20,000 hours use of the machine. So if you plot the electric compared to that, you see that by the end of the 20,000 hours, he's caught up and surpassed the savings in ice machine, and he's spent about 15% less cash to run an electric machine over a diesel. The other very interesting thing was even with the price of an electric at 1.7 times, you see that there's really no penalty in the first few years while he's paying off that financing. So he's got a higher finance charge, but he's burning less fuel, and the two pretty well offset each other. So what that means is that for the first 5 years, while he's paying this machine off, it doesn't really matter that it's more expensive for the electric machine because the fuel savings are offsetting that. And the real gains is once he's got it paid off. And you also see the big jump here at 12,000 hours. So if he didn't have to replace his battery till 18,000 hours or 17,000 hours, that jump shifts to much further down, and his cash flow is going to be much better, and his savings will be much enhanced over the time. Coupled with that, in a lot of areas, there are incentives. So if we put a 20% incentive in here, interestingly enough, right from the get-go, he's less cash out, even with the finance charges included at 8% interest. And by the time he gets to the end of life of the machine or 20,000 hours on the machine, he's about 25% less cash outlay. So in this example, using 10 years, 2,000 hours a year, which are realistic figures for these machines, he's saving considerably on his operating cost. So the point is that this is an economically viable equation, even as we work to get this diesel price, the electric price, more comparable with diesel, and to get these other factors in better shape. So one of the questions that people ask me is, okay, that works for an excavator, or we'll look at the excavator numbers, but what about with other types of machines? So we did the same analysis with our electric loader, 5-yard front-end loader, and we see here the energy costs are less than the excavator. So instead of 80% energy savings, you save about 69%. In other words, it burns less fuel than the excavator would. The repair and maintenance, we assume to save 35% baseline. If we had a complete battery replacement at 12,000 hours again, you save about 11% instead of 6% on the excavator. And the DEF, of course, you save 100% of, which gives you the curves for a loader that look similar to the excavator, little less savings over time because you're getting less fuel savings. But still, if you have an incentive to buy it of 20%, or if the price comes in more comparable here, you're still saving 20% over the life of the machine, which is a pretty significant number if you operate these machines. So the next question that people ask is, okay, if we're putting in these electric machines, we're converting our site as much as possible to electric. We're trying to gain all those systems, all those savings. So how do we recharge or refuel these new machines? So we look at it in terms of 3 ways to do off-road charging. So if you happen to be lucky enough to be in a site with grid access, that's obviously the easiest. There are grid connected chargers available. They're available for a number of different sources. The same chargers you use to charge your EV cars or Ford Lightnings or any other machines are applicable with these chargers, and they are readily available and easy to wire up on your site. If you don't have a grid run to your site, of course, we all know that running the grid to the site that's remote can cost millions of dollars in line charges and setup charges. So if you are in a situation like that, you may not have a choice but to go with portable power. So to take the electricity from a grid connection to the machine and recharge that way. And we are working, as well as a number of other companies, are working on portable battery packs or portable charge systems that can be taken out to a machine and recharge them. And remember, as I said, even if you go to an on-site generation, a diesel generator, you're still saving 30% of the carbon and still much more economical to recharge an electric machine that way than you are if you were running a straight diesel machine. But there are other on-site generation methods that we are offering through partners to our customers as well. So you can solar or wind regeneration. Some sites have hydropower available at industrial plants or industrial mine sites. Or you can even do biogeneration. You consume biomass and generate electricity from that is a viable method that we've proven out. This loader that you see in the picture ran totally off the heat and converted to electricity that was being generated from getting rid of the waste biomass they would have otherwise had to truck away, mulch, and produce the carbon through that operation. So the third part and the last part of my presentation is, okay, what do we need to do to run an energy efficient site? And our view here is we need to start looking at these remote job sites instead of job sites that are a number of tasks or jobs to be done. We need to look at them as a factory without a roof. So we need to look at the same analysis that we do in every one of our factories and production facilities and bring that to an off-road site. So the first step is to basically create your digital twin. We have the telematics on the machines, we have the AI systems, we have the tracking systems. We can set up each one of these machines with what are the transport, where are you digging up material, where are you depositing material, what are you doing with it, what are the value-added steps, what are the hazards in here and the bottlenecks. All the same considerations we have with a factory, we can do on our sites now very easily. And then with that, with the telematics and the AI, we can optimize those material flows and the energy flows throughout the site. So this is a science that's starting to develop. Volvo and a number of other companies are putting out systems that can help you manage these sites with a view towards sustainability efficiency, but also production efficiency and energy flows and energy efficiency as well. And if you do that, you end up with a thinking that you're going to optimize the entire site, not just the machines or tasks that are on the site individually, but you also end up challenging the assumptions and you're opening yourself up to new ways of working completely. So in other words, should we be using a conveyor belt electrically run instead of a loader moving materials? When you're looking at the site dimension, you can do that analysis very easily and come up with the right answer for your particular site, the right customized site design to run your site as efficiently and productively as possible. So with that, I will end. I like this quote. It came from Franklin D. Roosevelt, the 32nd U.S. president, actually our longest serving president. And one of the interesting things about this quote, it was for a Jefferson Day speech that he was to give April 13th. And unfortunately, it was never given because he passed away April 12th. He passed away the day before. But in his speech, he was going to say the only limit to our realization of tomorrow will be our doubts of today. And I think that's a very good quote, a very good thing to keep in mind. We have the technology, we have the energy, we have everything we need to realize this future we're envisioning for tomorrow. We just need to put aside our doubts and get to work in doing it and building these systems and building these sites that are more efficient, one step at a time, that will take us to where we want to be tomorrow. So in other words, as I started out, to build the world we want to live in. for tomorrow. So with that, I'll turn it over and answer any questions that you might have. Thank you very much for your attention.
All right. Right. That was fantastic. Very compelling case for battery electric vehicles for sure. Everyone on the call still, here's how you can connect with Ray here. Let's go through some questions. We have quite a few that came up. Certainly the benefits of battery electric vehicles are very clear. Um, Essentially, what do you think the biggest barriers are preventing you know companies from adopting sustainable solutions faster, and what lessons has Volvo learned in the last 5 to 10 years, and what would you do differently if starting today?
So I think Volvo, like a lot of other companies, and this is not a criticism, but um, I think everybody that was in this field that was looking at these technologies expected the change to be much faster than it is. And it's really when you start looking at the energy infrastructure and the total energy demands of our society and where the trends are going that you realize that even with phenomenal progress in renewables, we're still only at 9% in the US and 6% in the world that is truly renewable source of electricity. So that energy equation, or renewable source of energy, I should say, that energy equation, I think, to me, is the biggest barrier and the biggest learning to um, this path forward. A lot of people will point to the changes in the geopolitical and political landscape on this. I don't see that as being a big barrier. I see that as a temporary step in the road, bump in the road, if you will. In fact, some of the things that the Trump administration has done in the US in particular have been actually beneficial, because what it's done is it's brought the oil companies, the gas companies, the utilities um, to the realization that they have to be investing in these sustainable technologies as well. So it's brought them a long way away. So rather, the notion that we're going to eliminate all oil, now the talk is about, okay, what's the next step? What's the next evolution for the oil companies to become energy companies instead? So I see that as a positive uh, outcome of this bump in the road.
Okay. So based on what Volvo is observing globally, how do you guys see customer buying criteria changing over the last 12 to 24 months when it comes to electric machines? The conversation still being driven by sustainable goals, or now it's pivoting to operational costs or other factors?
So I think the first question I used to get asked in 2019, 2020 was, will the machine do the job that the diesel does today? I think we've proven that out. The electric machines, once operators get on them, in most cases, they don't want to go back to a diesel, and their performance is as good, if not better, than their equivalent internal combustion. So that's kind of gone by the wayside. The second question was, how do I refuel it? We're coming up with systems that answer that question. So we've now really come to the point where the TOC equation has got to be clarified and validated. The examples I showed today, we've got to do that on a much bigger, larger scale, and with many more types of applications and types of sites to really get those numbers in hand. And secondly, the notion of, okay, we need to convert sites, not just a machine. So unlike a car where you can have one car to take you back and forth, most of these sites have, 5, 10, 20 machines running around, and you really have to take a look at the entire site and changing the energy structure for the entire site, the infrastructure for the entire site to make a big difference and to make it viable.
Okay, next question. You mentioned the balance between social, environmental, and economic sustainability. In practice, which of these is currently the hardest to maintain in the construction equipment industry and why?
So the hardest to maintain from a technology point of view is probably the environmental. We've gone through a lot of new technologies, very complex technologies, trying to get the emissions down, the carbon down. So that, from a technological point of view, has been the toughest. The toughest from the economic point of view is definitely the cost of these machines. So as we scale up, the cost we expect to come down considerably, but the batteries are still a very expensive component of these machines. So that's been kind of a bottleneck or a barrier to widespread adoption. Um, Generally, society, we are doing, and I say we and the general industry, I think are doing a lot to try to get to meet society as best we can with what they want. So I think that's going quite well. But developing the technologies to keep going that next step and developing the economics around it and scaling up to the reasonable economic equation is the challenge right now.
Okay, I think we're almost out of time. I think we have time for one more question before we close it off. So, with rapid urbanization, how can the industry scale sustainably while meeting the increasing demand for infrastructure?
So I think the through solution sets that I talked about, the solution sets of digitization, AI, sustainable power, and automation are going to come into that equation. So there's going to be a lot more remote sites where you might have one operator operating three or four semi-autonomous or even autonomous machines, and producing what we need to move into the cities to feed the people, to get them the raw materials, the value-added materials that they need in the cities where the consumption's taking place. So I think the technologies that I talked about and the direction we're going is part of that, how we're going to solve that rural to urban equation or trend.
Okay, I think that's about time here. That brings our session to an end. And for everybody on the call, we hope you found the presentation was educational and insightful. Thank you again, Ray. Tremendous presentation there. Um, Appreciate that. Every session for the virtual conference is recorded and will be made available to all registrants once the conference has concluded. So that brings day one to an end. Hope you can join us tomorrow for another session. If not, big thanks from the Zappi Group for being part of the 2026 Future of Electrification Conference. Thank you, but hope to see you tomorrow. And thanks everyone. Thanks Ray again, and take care and have a great day.